straight into it. Okay. Calculate the impulse on a tree. Calculate the impulse of a tree on a 1,485 kilogram sports car if the vehicle is travelling at 93 kilometers per hour in a northerly direction when the driver loses control of the vehicle on an icy road and the car comes to rest against the tree. If the car crumples in 40 milliseconds, find the average force exerted by the tree on the car. All right. So, yeah, this guy's not doing well.
This guy is very not alive.
Yeah.
Very not alive.
So, there's our car. It's hit a tree. There's a tree. You can't see the leaves.
So,
Yeah.
good question. Does that mean that the amount of force the car exerts on the tree does the same back to the car? Right?
Absolutely. Yep. Newton's third law. All right. So, this is our north direction, and we will call that positive. So, south will be negative. All right. So, our impulse is just our change in momentum. So what is our final momentum of the car? 0. The car's come to a rest. Okay, so the final momentum of the car is 0. So all we need to do is work out the initial momentum, and that'll give us the change, because it's gone from whatever the initial is down to 0. So our momentum is equal to mv, which is equal to 1,485 multiplied by, now for velocity, obviously we can't use kilometers per hour. So we divide by 3.6.
Equal to about 20.
25.83 meters per second.
25.83 is the speed.
Yep.
Thank you. Can someone work out the momentum there?
About 38,000. Oh.
About 38,000?
0.5.
All right. So we're doing momentum. Well, we're actually it asks us for the impulse, so we can call this Newton seconds. Okay. So that was our initial momentum. We've gone down to 0. So our impulse is 38,362 Newton seconds. Now the thing is, impulse is a vector, so we need to give it a direction. What direction do we think that's acting in? South. Good. If it was acting north, the car would speed up. Okay, the change in momentum, if it was acting north, the car would speed up, but it has to counteract the velocity of the car, so it has to go in the opposite direction. So, 38,362 south. Okay, there's our impulse. But the second part, if the car crumples in 40 milliseconds, find the average force exerted by the tree on the car. So now we need our impulse formula. So our impulse is equal to the force multiplied by the change in time. So if we rearrange this, our force is equal to impulse divided by change in time. Our impulse is 38,362. Our change in time, 40 milliseconds, so that's 40 times 10 to the negative 3. Okay.
It's about 2.
What?
I don't know, it's a guess.
Yeah, evidently.
You use the common sense.
About a billion.
Right.
It's about 960,000.
I was close. I meant million. Oh.
That's a lot of.
Well, actually, let's just do 9.6 times 10 to the 5.
Oh.
Oh, do whatever you like, I don't care.
So what-
Now, force. Is it a scalar or a vector? It's a vector, so we need a direction. So, if the impulse is in the same direction as the force, then this will be in the south direction as well. Okay? So you just have to, for a question like this, work out the impulse, you work out the momentum before compared to the momentum afterwards, that is your change in momentum. And then, if you're given the time, you can use our definition of impulse to work out the force that's been applied. All right, any questions?